Dear participants, I welcome all of you in this lecture. And in today's lecture, we will discuss different type of operators, its precedence and associativity under Python programming. So, just to revise what we had discussed in last class, we have seen different type of data types in Python, such as integer, float, string, and so on. And we have already seen identifiers as well. So there are different identifiers and variables. Similarly, we discussed certain input output and how we can take multiple inputs from users and how can we split input into different sub inputs. So that we have already discussed in last class. Now, as far as contents of today's lecture is concerned, we'll discuss arithmetic operators, relational operators, assignment and compound operators, logical operators, bitwise operators, membership operators, and identity operators. So all we'll discuss in today's class, and we'll also discuss if suppose there are several operators in a particular expression. So how this will be executed. It means which operator will execute first, right? So how it will be decided. So it will, depending on the precedence and associativity, it would be decided. So that we'll discuss in today's lecture. Now, so the operators are actually special symbols that represent computations, whether you are performing addition, subtraction, or left shift operator, right shift operator, and so on. So the value or variables applied in the operators are known as operands. So for each and every operator, we are having associated operand depending on the type of operator, whether it is unary operator or binary operator or ternary operator. So depending on the type of operator, the operands will vary. If it is unary operator, then there would be only single operand. So if it is binary, so there will be two operands. And the type of operators are, like I have already discussed, like arithmetic, relational, assignment, compound, logical, bitwise, membership, identity operators. And one thing to be noted here, the Boolean data type can be used in arithmetic, relational assignment, and logical operators as well. So if you are taking a Boolean operator in arithmetic computation, so it will be treated, if true will be, it's a true actually, it's not, true will be treated as, it is true. True will be treated as 1 and false will be treated as 0. So, suppose you are having, you are performing a computation like a is equal to 1 and you have declared a Boolean variable. Suppose, b is a Boolean variable and you have taken it as a true. Okay, and you are performing a computation a plus b. So this will be treated as, true will be treated as 1 and the result would be 1 plus 1, 2. So in this way, let me take pen. So Boolean can be treated in this way. As far as arithmetic operators are concerned, so these are certain arithmetic operators like addition, subtraction, multiplication, division, and modulus operation, exponentiation, and integer division as well. So if I'm performing 5 integer division 2, so it would give me 2 actually. So it will give me the floor division. But if I am performing 5 divided by 2, so yeah, obviously it will give me 2.5, right? So this is the difference between division and integer division. And relational operator, the relational operators are binary. These operators compare the values on either side of them and return the value either true or false. It is especially used in, if conditional statement, we use a relational operator in conditional statements. Like if we are having equality operator, like whether A is equal to B or not equal, greater than, less than. greater than and equal to, less than. So there are several relational operators that we can use in decision making. There are certain assignment and compound operators as well. So assignment operators, like this one is the, suppose I am assigning 3 to A. So this is the assignment operator. And there is one more operator, that is we call it compound operators. A plus is equal to, suppose, 4. So what it will do? It will be treated as A is equal to 3 plus 4. If A is 3, then 3 plus 4, A is 7. So it would be calculated. So A plus is equal to 4 is actually A is equal to A plus 4. So this is the compound operator. So the condition with the compound operator, like in this case, so the value need to be initialized. It means if you are performing A plus is equal to 3, so first you need to initialize the value of A. Then only it would work. Similarly, you could perform this compound operator with division, multiplication, subtraction, and so on. Now there are certain logical operators as well. The logical operators are binary except not. So otherwise all the logical operators are a binary operator, whether it is AND or. So the logical operator consider operator either true or false. These operators compare the value on either side of them and return the value either true or false. So what logical operator would check? Suppose we use these operator in conditional statements. Like if I need to check if A is greater than B and A is less than C, right? So here I am combining these two conditions. So in this case, I can this type of operators can be used. Similarly, I can use OR as well. So if I am using OR, so if any of the two operands are non-zero, then condition become true. And as far as logical NOT is concerned, so it is used to reverse the logical state of the operands, right? So NOT, OR, and these all can be used in conditional statements. Then there are certain bitwise operators as well, like so the bitwise operators are binary except complement operator. There is a complement operator that is used for suppose there is one complement, two's complement. So we can use this particular operator, and this is for two's complement in Python. These are applied on corresponding bits in integers actually. So binary operators like binary AND or XOR and complement, so all will be applied on bits actually. So suppose A is equal to 3 and B is equal to 2, and if you are performing, suppose I am printing print A and B, so it will this is a binary operator. So what will be the value of this print? So A will be 3, it means 1 1, right? And B is 2 1 0, and I am performing AND. So what if both the bits in both the operands are 1, then it copies bit 1 to the result, otherwise it copies 0 bit. So it will be 0 and this is 1, right? So if you are comparing 3 with 2, so this will be the result, right? If I am comparing instead of AND, if I am using OR, then the result would be, suppose I am printing A or B, right? A or B. So what would be the value? Let me erase this one. Just erasing all these. And yes, A is equal to 3. Let's say B is equal to 4. So what would be the value of this print? So A is 3 1 1, right? And B is 4, so it is 1 0 0, and it will treat it as 0. So if I am performing OR, so if any bit is 1 in both the operands, so the result would be 1, otherwise it is 0 1 1 1. So it is 7 actually in this case. So similarly, XOR operation, if one bit is 1 and other is 0, then it copies bit 1 to the result, otherwise it copies 0 bit, right? So if it is 1 0 1 and 1 1 1, if you are performing XOR operation, then what would happen? If any bit is 0, another bit is 1, then only 1 would come. In this case, 1 1 0, 0 1 1, and then 1 1 0. Right? So this is the binary XOR. Then there is some left shift and right shift operators as well. So the left binary shift operator will move, operand to the left. Suppose I am performing a left shift 2 and A is 3. So what it will do? It will left shift the bits 2 times. So if I will represent A in the binary format, so what would be the A? A will be 1 1. And since I am performing 2 left shifts, so what would happen? It would shift 1 1 0 and then again one more shift. So 1 1 0 0. So this is the result of left shift. Similarly, right shift is there. So it will right shift the bits. And 2's complement, to 2's complement, there is operator. So it is a unary operator. They complement the operand in 2's complement format. Suppose 1 1 0 is there. So how it will perform 2's complement? First, the bit will be inverted, like 0 is 1 in 1's complement. 1's complement, it is 1 0 0. Then 1 would be added. 1 1 0 1 0. So it would be in 2's complement. So this is in 2's complement. So you need not to bother, right? All will be performed by the Python operator. So these operator will perform all calculation. Now there is membership operator, which is very important when you are considering any loop and you want to visit each and every element of a particular array, such as like list or tuple, set. So you can use in operators. So Python membership operator tests for membership in a sequence such as string, list or tuples. In evaluates to true if it finds a value in the specified sequence and false otherwise. Suppose I am considering, there is a loop. I will discuss a loop, how actually it works for I in 2, 3, 4. So it will visit each element in this list, and I would store 2, then 3, then 4. So in this case, the individual element would be visited, right? Similarly, not in, if the element is not in the sequence, so it will be treated in this manner. Now suppose what should be the value? Suppose I am giving you a expression here, like a print 3 and then 3 and 2 1 plus 3. Suppose you are storing this in a particular variable A. So what should be the value of this one, right? Since there are several operators, one is left shift operator, then XOR, then AND operator, bitwise AND operator, then there is a plus addition operator. So there are several operators. So which operator should be treated first? Which operator should be executed first? How it will be decided? So this is the task of operator's precedence. So Python maintains this precedence. So the parenthesis would be executed first. Suppose all these operators are there in an expression. So parenthesis would be executed first, then exponentiation, then complement, unary, plus, and after that into, divide. So this is the way the operator's precedence work, right? So in this case, in this particular example, 3 is so which operator would work first? Since plus is having, in this case, in this expression, plus is having higher precedence. So first it will be calculated, right? So how it will be calculated? So the result would be A is equal to 3 left shift 3, then XOR operator, and 3 plus 1 4, right? Now we need to check which in this expression, which operator should be executed first. Now we can observe that left shift operator is higher precedence as compared to XOR and bitwise AND operator. So then left shift operator would work first in this case. So what would happen? Left shift, it means you are having 3. So this is 3. You need to left shift 3 times. So 1 1 0, 1 1 0 0, and then 1 1 0 0 0. So this is the left shift of 3. Left shift of 3 times. So it is actually your what is the value? 8 and 16. It is actually 24, right? So it will be treated as, now it will be treated as, sorry. So I'm writing it here. Okay, I'm writing it here. So this is the first step, then second, and then 3. I'm writing it here. So you can write 24. So A is actually, A is 24, and then XOR 2 and 4, right? Now there are 2 operators, XOR operator and bitwise AND. So which should be treated first? You can observe in this precedence table. So AND operator should be executed first, bitwise AND. So it will be now 24 XOR, and what is bitwise, the value of 2 bitwise AND with 4. So 2 is actually 1 0 and 4 is 1 0 0. Now perform bitwise AND. So what will the value? 0 0, again this is 0. So it is 0 actually. So 24 XOR 0. So what will be the value of 24 XOR 0? 24 is actually 1 1 0 0 0, and 0 is 0 0 0 0 0. Now you need to perform XOR. So XOR, if there is a different bits, then only 1 would come, right? Otherwise it would be 0 0 0 0, then 1 1. So the result would be 24 in this case. So Python operates in this manner actually. So this is the result, right? So Python works in this manner. This is the operators precedence table. Now suppose there is one more case. If several same precedence operators are there in an expression, let's say A is equal to 3 plus 4 plus 5, and there are 2 addition operators. So which should be executed first, right? Otherwise, in this case, in this plus, it will not matter which one will execute first. But in several instances where the precedence is same, like complement and single plus operator is having same precedence, like in this case, you can observe, like this is the case. Unary plus and unary minus and complement is having same precedence. Similarly, into, divide, modulo, and then integer division is having similar precedence. So in case of this type of expression, the operators associativity would actually work. So when 2 operators have the same precedence, associativity helps to determine the order of operations. So which will execute first, it will be decided by the associativity. Almost all operators have left to right, so it will be executed left to right. So 4 plus 5, 9, 9 plus 3, 12. And as far as exponent is concerned, it need to be executed right to left. So suppose you are having 2 and 3, 2, right? So let me erase this one, it's not correct way. So I am erasing all these, and suppose you are having a value A is equal to 2, 3 exponential and operator, exponent operator, then 2. So which should be executed first? So it is right to left, right? Right to left. In this case, this will be executed first. Let me correct one thing. In the previous calculation, I said that A is equal to suppose 3 plus 2 plus 5, right? So in this case, it will be executed left to right. So first 3 plus 2 would be executed, then 2 plus 5. Finally, the result would be executed. 3 plus 2, 5, then 5 plus 5. Then in this manner, it will be executed. I said it wrong in the previous slide. Now, if it is having exponent operators, so exponent operator works actually right to left. So first this will be executed, and then it will come to the this side. So it is 3, 9. 3 to the power 2 is actually 9. Then 2 to the power 9, which is 5, 24, right? No, 512. Sorry, 512. 512. So in this manner, it will be executed. And there are some non-associative operators, like in this case, if you are having this type of operator, comparison operator, then here actually associativity do not works. So it is treated, it means it is neither x less than y and then z, nor x is less than and y less than z. It is actually equivalent to x less than y and y less than z. So as far as comparison operators are concerned, so associativity would not work in this case. So associativity actually is not in this case. There is some exercises are here. Write a program to read an integer and use bitwise operator to multiply it by 2. So when you apply left shift operator, if you are performing single time left shift operator, it is actually multiplying with 2. Suppose you are having a number a is equal to 4, right? And a is 4 and its binary equivalent is 100, right? So if you are performing left shift operator, it means suppose I am storing b is equal to a left shift operator 1. So what would happen? One left shift, so it will be 1000, right? One left shift. So now it is 8. So it means one left shift is actually multiplying it with by 2. 2 left shift is multiplying with again 4, right? And in the same manner. Similarly, if you are performing right shift with one time, then it is actually divided by 2, right? So in this case, in the question number 2, write a program to read an integer and use bitwise operator to divide it by 4, right? So what you need to perform? You need to perform, suppose the number is a and you need to divide it by 4. So what I will do? I will write a right shift with 2, right? So I will get divide by 4. If I need to perform divide it by 2, then I will use 1 only in this case. Now write a program to read the value of let me erase all these. So the question number 3 says write a program to read the values of 2 integer variables and use bitwise operators to exchange the value of variables, right? So let me use ideally, then I will write Python code for this particular problem. So what we need to do, we are having 2 values. Suppose I am using a is equal to, suppose a is equal to, you need to read actually 2 values from user. Int, first I need to typecast it, and then input, enter first number, right? And then I will write same statements here. I will store next number in B, right? And then I need to swap it, right? So I will write here print before swapping. I need to first display the values before swapping, which is A, comma, and then I'm giving some space, and B, right? Now I will swap it with XOR operator. So I will write here A is equal to A XOR B. Where is yes, A XOR B, right? So first I will XOR A XOR B. Then I will write B is equal to again A XOR B, and then again I will write A XOR B, right? So actually it will swap my two different values. I can use plus operator as well for swapping. Similarly, after swapping, so first I need to store it. Let's say a or test. I'm storing it with the name of this Python file is test, actually not test, test1. Then let me execute this one. I'm executing this one, run module. So enter first numbers, let's say 23. Enter second number, let's say 45. So you can see first it has before swapping this value, and after swapping this value 45 and 23. So in this manner you can swap the numbers, right? Let me come to the PPT again. So now we have seen how we can use XOR operator to swap the value. Similarly, there is a certain more question like, let me select the plane first. Yes, write a program to read the values of two integer variable and exchange the value using addition and subtraction operators. You can use what should be the value of 3, left shift 3, XOR 2, bitwise and 1, and then plus 3. So we have already discussed this fifth question. So this is the way you can solve the question using different type of operators. Now I am stopping here this lecture, and we will again meet in next lecture. Thank you so much.